Hi everybody. This lesson today is going to cover lesson 1.5, which is on inverses of functions. Hi, this lesson is going to be covering inverses of functions. What that means is we're going to take an inverse, we're taking a function and see if it has an inverse and talk about some of the characteristics. So let's go ahead and get started. First of all, what is an inverse? Well, go back and think about what are inverse operations. So we know that adding and subtracting are inverses of each other, and multiplying and dividing are inverses of each other. They are inverses, and that kind of means that they undo each other, right? They're opposites in a way. And that definition of inverse operations is going to help us, I hope, help us understand inverse functions as well. Okay, on this screen, I have two different graphs. They both show inverse functions. So for instance, do you see how one of them is a solid line? Let's call that solid line graph f of x, and we will call the dotted line graph g of x, and we'll do the same thing on the other one. We'll call the solid line f of x, and we'll call the dotted line g of x. F of x and g of x are inverses of each other. So let's go ahead and see what this sentence says. Above are some examples of inverses. It says inverse functions. That might be poorly worded. I got a little sloppy on that. We'll talk about that in just a second. The solid line is the original function, f of x, and the dotted line is the inverse of the function, and we will call that g of x. What do you notice about the graphs? I want you to stop the video here, and I want you to write down a couple things, at least one thing, of what you notice about the graphs. Okay, each of you might have said something different, but here are some things that are commonly noticed. That is, they're turned 90 degrees sideways, like this parabola. We had this parabola, and it's like we turned it over 90 degrees, and that gave us this one. That is a characteristic of an inverse. Another characteristic that you might notice is that there's a reflection, and I just think it's a little bit easier to see on graph A, but you can also see it on graph B. We'll show it there too. But if we took a line and kind of drew it like this, do you see how it reflects in that line? And we can do the same thing over here. If we took this line, we might start at this corner on this one. And we went through here. Okay, we would essentially be looking at a reflection in that line. Now the question is, what is that line? Well, that line is the equation y equals x. I didn't draw it very well here. I'm going to redo that here in just a second. Okay, that's a little bit closer. But this line and this line both are the line y equals x. So there is a reflection in that line. And again, this line is probably not perfect, but it's actually pretty close. I fixed it a little bit so it goes a little bit more through the center. I was looking right there and it wasn't going perfectly. Okay, so that's something that we should notice about inverses, is that they are reflections in the line y equals x, and they're turned 90 degrees sideways. There are some other characteristics, but those are two that are pretty easily visible. You might have come up with a different one, and that's totally fine. We will continue to talk about some of these. Okay, the next thing I want you to do is I want you to create a table of values, a table of points, table of values from the function and the inverse. Do this for each graph. So in other words, if this is f of x, and I picked some that went through so you could do it a little bit easier. So for instance, if we look at the graph and we're looking at f of x, that was the solid line. At the point 2, we're at 2, 0. And at the point 4, we're at 4, 1. Okay, so continue to go through and just fill in those last couple of boxes there. And I think in the table it would be helpful to change that from a 9 to an 8. Isn't that where it goes through? I think I was reading that backwards, but goes through the point 8, 9. Yeah, so change that to an 8 and then a 9 here. On the 7, I estimated that 6.1 approximately. Okay, what I want you to do now is look at the points on the other one, the dotted line. So let's take a few seconds for that. So if we look at the 0, for instance, 0, 2 is one of the points. The next point is at 1, 4. All right, I wonder if you're seeing a pattern here. Go ahead and fill in the rest of the table. Okay, so here are the rest of the points. Are you recognizing what's going on here? Okay, you should see that these are like, again, it's kind of like a reflection in a way, right? That we've gone through and looked at these and they're reflected, they're switched. Let's look at it for graph B. Take a few minutes to fill in both tables on graph B. All right, here's what I came up with for those two tables. Now, did they do the same thing? That is, were they like a reflection? Well, the way I wrote the values isn't totally the same, So maybe let's go back and redefine. Rather than saying this is a reflection, although it is, and on the graph it is as well, what can we say it another way? What if we say we switch the x with the y? Would that make sense? So here we have the x, it came over here and became the y. Here we have the y, it became the x. So the x's and the y switched. So let's look at that graph B in that way. Did it switch the x with the y? So here I have a point negative 4, 5. Here I have the point 5, negative 4. It switched it, didn't it? So that one does. Negative 3, 2. Here I have the point 2, negative 3. That one also switches. Negative 2, 1 is here. 1, negative 2. Negative. Okay, so they're all switching. Okay, so yes, it does switch the x with the y. Now maybe you're starting to see that there's something wrong with what's going on, and what's wrong with it. Well, first of all, before we talk about what's wrong with it, let's go ahead and write that down. I know I wrote it down up here, but let's write it in the blank here. It says, what do you notice about the relationship? The x's and the y's are switched. Okay, that's what's happening here. Well, what does that mean for the domain and range? Remember that the domain represents your x values and the range represents the y values. So if we switch the x values and the y values, what happens to the domain and range? Well, they also switch. So that's something important to know as well. We're going to come back to what's kind of wrong, what's going on wrong here, and we're going to come to that in just a second. Let's turn the page. Okay, here's what the problem is this word over in the margin, invertible. Another way to say this is one-to-one, and we're going to dive into that here. So in order for the inverse to also be a function, the original function must be a one-to-one function or invertible. That is, a one-to-one function has exactly one x for every y. Let's go back to the other page for just a second. And let's investigate that a little bit further. Let's focus on graph B. Is f of x a function? Yes, it is. Passes the vertical line test. Is g of x a function? No, g of x is not a function. And so that is what I was alluding to when I said some of you might be realizing that there's something wrong with this table, right? Like even when you were filling it in, you might have thought it was kind of odd that we have 2 2s and 2 5s. It is odd because that's not a function. And that's actually an important distinction that we're going to make is when you switch it, does it create a function? Or when you switch it, is it not a function? And so in this first example, our f of x was our original function. When we flip that over, is it still a function? Well, if we take our vertical line, does that vertical line work? Only looking at the dotted line? Yeah, those are actually both functions. This one, though, is not a function. Okay, let's go back over to the other side and continue our discussion there. Okay, a one-to-one function has exactly one x for every y. So, we've been talking about this a little bit, and you've talked about it more in middle school, but how, some tables of values might go like this, and some table of values might go the other way, but some table of values are really obvious, and it's like they're all straight across, right? That is a one-to-one function. It means for every x there's only one y, and for every y there's only one x. Okay, so this is really easy sometimes for us visually to understand is that these are not functions, but if it's like this, they're all just one-to-one, that is a one-to-one function. Okay, in order for the inverse to be a function, the original function must pass the horizontal line test. Well, that's a little bit confusing because we've been talking about the vertical line test, but now we're talking about the horizontal line test. The horizontal line intersects the function's graph more than once, then the function is not one-to-one. It's still a function, but it's not one-to-one. Let me show you what I mean. Okay, this function, first of all, this is a parabola. Is a parabola a function? Yes, it passes the vertical line test. Okay, I drew a horizontal line on here, but if I drew it vertically, okay, does it pass the vertical line test? Yes, it does. So it is a function. But does it pass the horizontal line test? No, it does not pass the horizontal line test. Therefore, even though a is a function, its inverse is not a function. That means it is not one-to-one. Okay, I wrote that over here in the margin, and I typed it out because my handwriting gets kind of messy on these boards. But the original is a function. but it does not pass the horizontal line test, so the inverse is not a function. Therefore, this is not a one-to-one function. Okay, let's look at the other one. Think about the vertical line test, think about the horizontal line test. Is this a one-to-one function? Okay, so again, I typed my answer over here. It does pass the horizontal line test. It also passes the vertical line test. Therefore, it is a one-to-one function. Another word for one-to-one function is invertible. And I just tell you that because sometimes there are different textbooks or different tests that might use the word invertible. And invertible means, is it one-to-one? Can you do the inverse and the inverse is still a function? Okay, so this is invertible. Okay, the next one has a couple different variations, but just, kind of further looking into what are inverses. Do they show inverses, and are they both functions? So let's take a look. Okay, let's look at this drawing. Do you think those are inverses? And I'm going to ask a second question that wasn't really in there, but I'm intending this to be part of the question. If they are inverses, are they both functions? Okay, so think about that. Okay, remember one of our definitions is you could rotate it 90 degrees, or you could reflect it in the line y equals x. These do appear to be reflected, don't they? Are they both functions? Okay, I think we can see that that second one is not a function. Okay, so I wrote that there. They are inverses, but the inverse is not a function. It does not reflect over the line y. Oh, it does reflect over the line y equals x, but the inverse doesn't pass the vertical line test, and the original one doesn't pass the horizontal line test. Okay, so we've got a lot of going on there. All right, how about these? Are these inverses of each other? Well, are they reflected in the line y equals x? No, those are not reflected in the line y equals x. There does appear to be a reflection, right? Where is that reflection? I think that reflection is there on the axis, don't you? So it's the wrong reflection. So no, they are not reflected over the line y equals x. They're reflected over the x-axis instead. Therefore, they're not inverses. Okay, it's just a reflection. That's all it is, just a reflection. It's not an inverse. All right, on this one, I want you to practice. I think, we've talked about, there's a couple things going on with the inverses. For the inverses, they switch the x with the y. So I'm trying to help you out with the table, switching the x and the y. Another thing with inverses is they reflect over the line y equals x. So that's another thing we're going to do. But we're going to take a look at this and we're going to do it. Not just can you look at it and identify it, but then can you actually make it? All right, so take a minute to find the coordinates of this original graph and put those in the table. Okay, so I put in my points. Before we go on to the inverse of that table, let's talk about this. Is this, when we do invert it, can you imagine what it's kind of going to look like? Is this a one-to-one function? One-to-one function, we can look at the table, or we can think about the horizontal line test. Okay, I can already tell that when we do the inverse will not be a function because it's not one-to-one, and that's going to make it not a function. Okay, let's go ahead and switch our x's with y's. So in other words, the 6, -3, -2, -3, 6, I'm going to put those in the x column, and the other numbers I'm going to put in the y column. Okay, so again, maybe as you filled it in, you could kind of tell it's not one-to-one because we're repeating the 3, we're repeating the 6, or -3 and +6. So that's not going to be one-to-one. Let's go ahead and graph those points. All right, here are my points, and sometimes it helps to kind of imagine what you're going to look at. So it's kind of this W shape going this way. So when we flip it, it's going to be kind of a sideways W. I'm not the greatest on drawing on this board, so I'll do my best, and you do your best as well. Okay, so I went ahead and also drew in my line of y equals x because that's kind of a key part of the system, right? I mean, we kind of need that sometimes to see. But it should be, like I said, a sideways W. Mine's not great. I did my best. And here is my line y equals x. All right, so we have talked about several things about inverses. I can think of at least 2 off the top of my head, probably 3 that we've talked about. Can you write down a couple things that you need to remember about inverses? And then we are done with today's lesson. Make sure you write your questions in the margin. If you have questions, write them down, bring them to class, and I can answer your questions next time.